This video will explain that the aurora borealis is visible light. The diagram below shows that visible is in between infrared and ultraviolet. It also shows the rainbow and how it starts with red and ends with violet. And also shows that visible is not as harmful as ultraviolet, but is more harmful than infrared. This is what we can see. Visible light is the part of the electromagnetic spectrum the human eye is most sensitive to. Electromagnetic radiation with a wavelength between 380 nm and 760 nm is detected by the human eye and is perceived visible light. Because the auroras are transverse waves, they move perpendicular to the direction the wave is moving in. They also have crests and troughs. The crest is the top of the wave and the trough is the bottom of the wave. The wavelength is the distance between any two corresponding points on a wave. The wave goes from crest to crest or trough to trough. The amplitude goes from rest to position to crest or rest to trough. It is either high amplitude or low amplitude. The frequency is the number of waves that pass a certain point in a given amount of time. The auroras are the result of collisions between gaseous particles with charged particles released from the sun's atmosphere. Particles escape from the sunspot regions on the surface, hurtling particles of plasma known as solar wind into space. Generally, it happens when there is an opening in the sun's atmosphere that allows electrons and protons to flow out. When the charged particles are blown towards Earth, they are largely deflected by the Earth's magnetic field. However, the Earth's magnetic field is weaker at either pole, and therefore some particles enter Earth's atmosphere and collide with gas particles. That is why most of them happen in the poles. These collisions emit the light and colors we perceive. The colors most often associated with the aurora borealis are pink, green, yellow, blue, violet, and occasionally orange and white. Typically, when the particles collide with oxygen, yellow and green are produced. Interactions with nitrogen produce red, violet, and occasionally blue colors. These lights may manifest as a static band of light or when the solar flares are particularly strong as a dancing curtain of ever-changing color.